All right, so in our warm-up, we saw that when you have a function within a function and you take derivative, you need to use chain rule. I want you just to forget about the words for a second, and I want you to look at this inside part right here. Do you see how this is the derivative of something that applied chain rule? Like the derivative of the inside part right here is sitting right next to it. Okay, what we're going to do is go backwards from here. And I'm going to give you a really good method. It does have some steps. I don't want you to be too focused on memorizing the steps, but I want you to understand the system. And at the end, I'm going to give you a really easy way to check your work. Okay, so when you have an integral like this, we could not just use our antiderivative rules from earlier in chapter 4. Because this is not written as a number x power. It has more complicated stuff in here. In particular, it has something in parentheses to a power, and that's the most common type of these types of problems. If I wanted to do this using my old methods, I would have to do a lot of simplifying and then do it. But we have something called integration by substitution. We're going to call this U sub for short, and we are going to utilize a method of taking something complicated and then replacing it with just a single letter. It's going to simplify the process. As long as you're thorough, it works. So I'm going to go ahead and tell you what we're going to let u equal. Eventually you need to get to where you can figure it out for yourself, but for right now I'm just going to tell you we're going to let u equal x squared plus 1. So looking at this problem, you can kind of see what makes this special. It's the thing in parentheses to a power. So we're going to replace that x squared plus 1 with a u. So this will just be the integral of u squared. Now you got to deal with the other part here. So that's what the second piece is for. Okay, now moving from this piece to this piece. Do you see how we can say the derivative of u is du? Does that make sense? All right, and then what's the derivative of, we'll take the derivative of the other side. So what's the derivative of x squared plus 1? 2x. Now writing this dx here is not going to be as intuitive. Think of it like this. We're saying that this 2x is the derivative with respect to x. All right, so when we're doing this u substitution, we're going to have to go du equals something, and then we're always going to have to write dx there. It's going to be part of the process. It's stating that that is the derivative of my u. All right, and so look at how this gets rewritten. Hold on. Real quick, before I even look at that. See how 2x dx is equal to du? And there's a 2x dx right there. We're going to replace that with du because it equals du. So I have an integral u squared du. Again, I don't want you to be like, I can never memorize all these steps. We're not there yet. This is the very first time we're talking about this. I just want you to see how I'm substituting in a u in for this thing and a du in for that. Integrating this piece is now pretty easy. All right, it's a u instead of an x, but you just say what's the antiderivative of u squared? That would be 1/3 u cubed. Remember, when you antiderive, you no longer have an integration symbol or a du or dx or whatever it may be. And then plus c. So here's my answer, but it's in terms of u. So just one quick substitution back. In place of u, we put the x squared plus 1. So this kind of explains the steps. All right, now we're going to practice this because that's really how most people learn, is by actually doing problems. Okay, so let's start with this first one. Okay, do you see how this is more complicated than the problems we've worked before? We've dealt with a 5 in front, but we have not integrated where the 5 is inside the cosine function. All right, this is like a chain rule. This is how I know I need to use u substitution. So the first thing is I'm identifying the u. We're still not really great at that yet. We're just starting out, but this is one way you can know what your u should equal. So I'm going to let u equal that thing. Since it's not just a plain x, it's more complicated. I'm going to make my u 5x.
So why did you decide that with the u instead of cosine?
Well, cosine isn't, your u is always going to be something with x. Like cosine doesn't mean anything without a function. And so u is going to be like a term with x in it. All right, and then you're going to take derivative of both of these. All right, because when I do my substitution, I got to get rid of dx. And I'm going to say, okay, what's the derivative of u? It's du. What's the derivative of 5x? 5. And then dx. This is not natural yet, but it will be really soon. Okay, so watch what is about to happen. Okay, I'm going to write my integral symbol. And instead of cosine 5x, I'm going to say cosine u. Because this, I can antiderive. It's just like if I was antideriving cosine x. Okay, what else was in the problem? This dx was in the problem, and here's a dx right here. I'm going to substitute out this dx, and I'm going to say, okay, well, over here, what equals dx? Well, this 5 is kind of in the way. So how could I move it to the other side? I could divide by 5, or I could write 1/5. I'm going to go ahead and use this because it's going to be more useful for what we're using. Okay, so look what I'm going to do. Instead of writing dx, I'm going to write what dx is equal to, which is a 1/5 du. Okay? All right, now, this 1/5, and we're going to see this happen in a lot of the problems, it's just a number being multiplied. So I am going to move it to the front. So I'm going to write 5 integral of cosine u du. And this integral, it's not much simpler than what I started with, but it is simpler.
How did it turn to 5?
Oh, it doesn't. That's just me being dumb. What should that be?
1/5.
Thank you. 1/5. Thank you. That's me talking too much while I'm writing. All right. So what I was saying is this integral of cosine u du, it's a little bit simpler, and it's something that I can do. What is the antiderivative of cosine u? Sine u. I couldn't do this until it was just a plain u. I couldn't do this with the 5x. All right, and then don't forget plus c at the end. And that's my answer, except it's in terms of u, and remember my original problem is in terms of x. So I got to do the substitution one last time, and instead of u, I need to write what u was supposed to equal, 5x. Okay, so this is the first example we've done together besides the one at the top. So we're not perfect at this. We don't understand it 100%. So let's get the questions out of the way.
Why did you not do anything with the du when you integrated?
Every time you integrate, there's always going to be du or dx or d whatever here. It's basically stating that that is the derivative of u. So the whole reason the du is here for notation purposes is stating that this is the derivative of u, and as soon as you antiderive, it goes away.
Okay.
And that happened when we had dx as well.
Okay.
I do want to point out something. See how we started with only x's? And then we had only u's, only u's, only u's, and then your final answer is only x's. I never had u's and x's right next to each other. We can count on that, okay? That's a common mistake. If you start getting u's and x's like right next to each other, I'm not talking about up here, but like on the same integral, something went wrong and we need to fix it. Okay, so that was the first example. We need to do another example. Okay, so 2 is a lot like the one that was in the top paragraph. if I was going to just use my old integration rules for this, I would need to do a lot of simplifying. Squaring this out, distributing the x, all that. Okay. But if I notice I have something in the parentheses, okay, being taken to a power, I can let u equal that thing. And we'll worry about the x in the front in just a second. So then what would du equal in this problem? 2x dx. And you're multiplying all of this. This is like 2x times dx. Okay, here's where everything else kind of comes into play. Okay, you write your integral symbol. I'll get to this x in a minute, but for now, x squared plus 1, that's a u now, so I'm going to write u squared. Now, I can't write x, don't write x here, don't write dx. What we need to do instead is think about what does x and dx equal? And you should see an x and a dx in this second line. Okay, and I see it. I see an x and I see a dx. Is there anything that's in the way? The 2. So we're going to do the same thing we did in the last problem, and I'm going to divide that 2 over to the other side. And as I take out the x and the dx, I'm going to replace it with what it's supposed to equal, which is 1/2 du. So the idea here is that once you set what u equals and du equals, that you replace everything in the problem. Instead of in terms of x, now it's in terms of u. In fact, if this first x had not been there, we would have had a big problem. We wouldn't have been able to do this because there really needed to be an x in my problem. I can't divide over an x. I can only do that with a number. All right? And I know I'm not supposed to have u's and x's together. So it was good that that x was there. If it hadn't been there, I would have gotten stuck. Okay, once you get here, this really is like climbing a tall mountain and then snow sledding all the way down, because this should be pretty easy to integrate. Like for instance, that number, I would go ahead and just move it to the front. Now, if you notice, we've done this 2 times. We've moved the number to the front. If you feel comfortable with just writing the number in the front from the get-go, that's totally fine. And that may happen today, that may happen after we get really good at this, I don't know. But that number is going to go to the front. Okay, what is the antiderivative of u squared? 1/3 u cubed, and then plus c. So then 1/2 times with 1/3, that would be 1/6. Instead of u, I need to go back to my original problem and go, okay, what was u equal to? It was equal to x squared plus 1. And that's your answer. All right, I kind of told you guys earlier that there was going to be a really easy way to check your answer. And it's no, like, secret. It's no magic. How do you check an antiderivative? You derive it. What rule do you think you're going to need to use to derive these answers? Chain rule. All right, and so I'm not going to write all this out, but mentally I can see here, derivative of 1/5 sine 5x, that would be 1/5 cosine 5x times a 5, and then the 1/5 and 5 would cancel. You'd get what you started with. Here, I would have 3 times a 6, that'd be a 1/2. Inside, this power would decrease by 1 to the squared, and then I'd go times 2x. So the 1/2 and the 2x would just be an x. So you can check your work that way, and of course, you can check it on your calculator as well. Okay, so this is the first day we're doing this. We're going to kind of sit on this and spend a lot of time here. Although there's different types of problems, it all follows the same steps, basically. So the first thing we need to do on something like 3, we should be pretty comfortable with, and that is rewriting. Okay, let's rewrite this squared to be more like how it really is. Let's make it parentheses sine 3x in parentheses squared. The other thing is the parentheses make it more obvious what u should equal. In the previous trig problem, I let u equal the 3x. That's going to make this a little bit simpler, but not really that much. Anybody have another idea of what we should let u equal? Yeah, the thing in parentheses being taken to a power. So let's let u be sine 3x. Then what would du equal? Cosine of 3x times 3 dx. I'm kind of getting into the space over here. All right, so let's look at what we got. We got an integral symbol. Instead of sine 3x, let's write u. So this is going to be u squared. Okay, and now what should happen is everything that's left in the problem should be right here. If it's not, we did something wrong, or it's a much more difficult problem that we're not ready for. But we do see it. I see the cosine 3x and I see the dx. Right here. Here's cosine 3x, here's dx. The 3 is in the way. By now though, I think what should we do? Yeah, divide it and let's make that a third. So this whole thing becomes 1/3 du. See, I'm just getting that from right over here. 1/3 du is equal to cosine 3x dx. So I'm just doing a swap. Okay, move the third to the front. And if you feel comfortable just going straight into that, that's fine. Okay. What is the antiderivative of u squared? 1/3 u cubed plus c. So then the answer would be 1/9. And then in place of u, just go right up here and look at what you said that was supposed to be sine 3x and then plus c. And then you can easily check this by deriving. I'm not going to do that right now, but okay. It's a system. I want you just to understand overall how it works. Don't worry about memorizing the steps. If you practice this enough, you'll know the steps. Okay, what do you think we need to do on number 4? Rewrite it. How would we rewrite it? Yep, we've been doing that kind of stuff all year. Okay, you go ahead and write down what you think u should equal. Okay, anybody want to share? (2x minus 1), the thing in parentheses. Okay, so then the next step would be to do the du. Don't skip the du step. This is really where most people make the mistakes. They think they know what's happening next, and then they mess up here. Make sure you follow through. This would be 2 dx. Even though there's no x's here, you'd still write dx because you took derivative of an x term. We have our integral. We have the u to the 1/2. What do I have left? I just have a single dx left. So what does a single dx equal in this problem? 1/2 du. And again, notice I only had x's and now I only have u's. You got to make a clean swap. You can't go half and half. So the 1/2 goes to the front. Hopefully you're leaving yourself some more space than I am. What is the antiderivative of u to the 1/2? If I go 1 over u, 3/2 is the power. And so I put 3/2 down there. So there's a couple of things you can do here to simplify, although it's not required, but we need to know how to do this. You could just leave it like it is and go 1 times 1, and then what's 2 times 3/2? 3. You could change this thing right here to 2/3. Either way, you multiply those two numbers together, you get a third. And then again, in place of the u, go ahead and write in what u equals. And don't forget your plus c. I've already said this a lot, but what goes in the answer blank? You check your answer by deriving. And so I haven't done that on each of these, but that's how you do it. Okay, if you look on this next page, here's some examples. I really want you guys to come in having tried 4 of these tomorrow, because I want you to come in tomorrow having questions. Okay? Be here tomorrow.